We are live. Welcome to the Listen to This Bull live show. This is the show where we talk about bullshit in the insurance world. Anything really that has to do with bullshit. And it's live, so you can ask questions live. And we'll answer them. You can ask anything you want. You can ask what material my hat is made of if you really want to. I have no idea, but I'll try to answer those kind of questions. My name is Matt Mulholland. Remington Huggins is normally my co-host. He's not able to be here today. He said he was sick. I think it was anal contusions or something along those lines. Not really sure. But he'll be with us next week. I've got Andrew Behrens here. Andrew, hi.
Hi, how are you? It's good to be here.
I'm good. How are you doing?
I'm doing really good. How are you doing?
We're going to talk about low slope roof materials and other things about low slope roofs today. I think you're the perfect person for that. But before we do anything, I got to hit this button. I can't wait to show Remington that I told everybody he had anal contusions live on this show.
Yeah, that was a good one. He'll love that one.
I think he's going to really enjoy it.
Sure he will. How many hats do you have, Matt? Let's just get that out of the way.
I have 4 of this hat.
Oh.
Which doesn't do much for the brand because, you know, it's a very special hat. But, you know, they get old and ratty after a while, so you have to replace them. Luckily, they keep selling this exact same one, and I can just keep purchasing it.
I would not want to smell your hat. That's all I know.
Yeah. So I've lost a few of them over the years, left them at different places. It's not good.
Yeah, well, you got plenty of backup, so that's a good thing.
Yeah. Yeah. Where's your hat?
You know, I'm not a hat guy. I mean, look at me. Look at my hair. I actually like what's your hair looking like these days? It's been about, I don't know. Have I ever seen your hair? I don't know. Oh, there it is.
See, I mean, it's got hat hair.
It's great.
Because of the hat.
Yeah.
But I got hair.
Yeah, looks good.
I think most people, well, I definitely am losing some. But I should lose a lot more than this before it's a real issue.
How old are you, Matt? You're 30?
39.
39? I was going to say 38. 37 maybe. But
really? It's because of my glowing good looks.
And maybe your hat.
It could be the hat. The hat keeps me young. It keeps the UV radiation off.
It is pretty funny in your Facebook profile pictures, I will say.
Yeah, there you go. All right, so we're going to talk about low slope roofs. And if you guys have any questions in the audience, feel free to post your questions online. We'll try to answer them as best we can. We're going to get through some interesting parts of this. And I know that we could go in like 15 different directions with it. So the audience is really going to drive the conversation. You have to be a part of the conversation for us to get to where you want us to go. But I'm going to start with you and get a little background from you real quick, Andrew. For the audience's sake, tell them why I would have you on this show when we're talking about low slope roofs.
Yeah, for sure. So those of you who don't know me, I was with C3 Group for about 11 years. And I ran their investigations department. Pretty much everyone knows C3, I'm pretty sure, but they're a great group of people. One of the best public adjusters out there, in my opinion, really like honest and fact driven, which was, you know, always a huge thing. But in my time there, I noticed a lot of deficiencies, at least on the low slope roofing side. I mean, really in any assessment of any building material, but on the low slope side, it was interesting because, you know, even the people that were the best in the industry assessing it, they didn't pay attention to certain things. They didn't really understand how complicated the assessment process is. And it's not like slope roofing, you know? So I got a lot of exposure just by coring roofs, you know, just being constantly exposed to different building materials. And I was really in charge of representing, you know, these damages in an estimate ultimately to a carrier or to our adjusting staff that would submit that to a carrier. So really open up to like scrutinization on my end. So it kind of led me to look further into, you know, what constitutes damage to this product and this product and this product, you know, because you get the general responses and you're like, all right, I need to be more technical, more technically driven. And it kind of led to, you know, seeing a lot of building products, seeing a lot of different roof assemblies, working really all over the United States and seeing, you know, the variables there. And yeah, it's turned into a lot of information that you're like, wow, that's, you know, it's been a lot over the past 11 years. But yeah, I would say low slope roofing has kind of been my focus, and one of the areas I think is more deficient than others, I would say.
Right. So you're a total nerd, which is why I like you.
Total nerd. Yeah.
Total nerd. Miguel says You.
Yo,
Oh.
come on. Sorry, Miguel.
All right. I might have known. It was you.
Yeah, maybe.
Yeah, maybe. It could have gone either way. It's ambiguous. So, from a low slope perspective, there's a lot of misinformation that's out there. There's also a lot of confusion. There are a lot of contractors that I worked with over the years that wanted to get into low slope roofing claims or just to transfer over from a retail perspective into getting into low slope stuff. And everybody, they say flat roof a lot, which is a misnomer. Although you can come across a flat roof.
Yeah, you definitely can.
You can.
Quite frequently, actually.
Yeah.
But yeah, I mean, you hear for use both. But yeah, I mean, usually you'll run into at least an 1/8 inch per foot, 1% slope. So low slope, I guess. Yeah.
All right. So Miguel asked an interesting question. Isn't damage anything that contributes to a lesser lifespan of a product? I'm so glad he asked this.
Yeah, it's a great question.
What is damage, Andrew?
Yeah, so I mean, I would say anything that alters, the value, usefulness, or normal function. That's really the Webster definition, and something I bring up in class a lot when I teach. And really, it's kind of getting the point across, that most parties, and I'll get to Miguel here in a second, but leading into that, a lot of parties when they're assessing low slope claims and really any claim, I mean, you have different backgrounds, different perspectives. You have people that are policy driven, people that are kind of emotionally driven, people that are professional driven, meaning like you're an engineer and you pay attention to function your whole life. Are you going to have the same definition of damage as an adjuster or a building owner or a building manufacturer? No. So yeah, I mean, I would say yes to that. I mean, I think if there's any reduction in serviceable life, then yeah, that should constitute damage. Of course, that's pretty general. Right. Usually I like to be a little more technical than that and be like, well, why did it decrease the serviceable life of the roof or that building component, not just the roof? But he said product. That's a really good question because
he did.
It is product based. It's product specific, not roof covering, based. So
I'm going to take a different turn on this and a turn that I've never taken on in any format in anything for this question, because this question has been on my mind quite a bit lately. When we're talking about what damage is, that word damage doesn't really even matter most of the time. Most policies pay for sudden and direct damage or loss, accidental direct physical loss, direct physical damage to or loss of the property. And then it goes, we will insure for loss caused by or causes of loss. And then it uses the word loss. It doesn't use the word damage. There is a difference between damage and loss. Loss doesn't need to have a physical alteration to the property. So here's an example that is a little bit out there. I got this example from Leland Kuntz, who I hope is listening to this because he sent me off in this direction the other day, and I'm so glad he did. His example was if the door gets flung open from a wind event and leaves blow into the house, and that's it. There's no rain that gets in, just leaves. Is the floor damaged? Someone has to clean it up, but the floor isn't physically altered. There's no detriment to the floor after the leaves are gone. They're just moved off of it. There is a loss because someone has to do the labor to do that. That's the difference between damage and loss. Loss doesn't have to have a physical change to the property. It doesn't have to show a reduction in the lifespan.
Yeah, so, that was a good analogy for sure. I mean, great. something that I think of a lot is like polyisocyanurate, polyiso, whatever. I mean, when you get fractures of the facer or compression, I mean, a lot of people don't consider that damage, and even if you were to quantify thermal loss, the equivalent of that to like, energy savings losses over the lifespan of the roof, and you were to quantify the dollar figure, I mean, that's more of an indirect loss, not direct physical damage, even though of course the compression and facer fractures are. It is interesting when you come across an individual that doesn't really consider that damage, and you can kind of use the indirect quantification to show that it is direct physical damage.
Yeah, I mean the terms direct and indirect are very specific to a contract form and things. So direct physical loss is going to include any loss that occurs in that same chain of events from the same cause of loss or the same proximate cause or primary cause. Whatever starts that chain of events off, everything that occurs, even damage that occurs during repairs, that's all part of direct loss. It becomes indirect when it is completely separated from that chain of events, or from that causal chain. If Additional living expenses is a good example of an indirect loss. It's a financial burden outside of it. Maybe you have to shut down your business operations. That's a form of an indirect loss. That's separate from the physical damage that has occurred.
Yeah, caused by or resulting from. Yeah.
Right. It's still part of that whole chain of events. It still is occurring because that loss has occurred, but it is indirect from that damage. So, but we have to remember, most policies pay for direct physical loss, and they pay for perils which are a cause of loss, not necessarily a cause of damage, although sometimes they will specify damage or loss or just damage, and it is a different thing. So for you public adjusters that are listening, start paying attention to when it says damage and when it says loss. There is a difference there. So if the policy pays for loss caused by something, and then they claim, well, that damage is only loss of lifespan, then that doesn't mean the same thing that as a loss does. Loss, it can be many different things. So it has to be very specific. Anyway, I haven't really gone into that before. I know that's a little bit above most people's heads.
It's a good point, Matt, too, because those definitions, like they're either misapplied or misinterpreted, or they're just misdefined in general.
Yeah.
So, I mean, and that's where, you're really good at that stuff. Obviously, everyone knows that. And I'm kind of like that on the estimation, the code compliance, the damage assessment side. But I mean, that's, and that's too, where like you're really focused on the policy interpretation side. I'm kind of focused on damage assessment and code compliance.
I think that we can benefit the audience quite a bit today by taking those two separate perspectives. So let's get back into the whole damage argument anyway. I recently had an argument with Steve Badger on LinkedIn regarding damage to the substrate. And you mentioned polyisocyanurate or polyiso or ISO or whatever you want to call it, the foam insulation. What do you call it, by the way?
Substrate. Is that what you're referring to?
Just polyiso specifically. Do you call it polyiso?
I mean,
what's your pet name for it?
If I'm writing a report, I'll name it and then call it ISO or polyiso. But yeah, I mean ISO.
Yeah. ISO, yeah. I was called ISO beforehand.
Yeah.
And then you taught a class that I was part of, and you called it polyiso, and I've been calling it polyiso ever since, which is the most accurate short version of the actual name of the ship. But anyway, so if there is damage to polyiso, but there's no damage to the covering that's on top of that, does that mean that there's no covered damage?
Well, it's funny because and you were in the class that I taught, the 5-day class, but it's like, that's where, obviously, like I don't necessarily fault Steve Badger, honestly, for taking that approach, because I think that it is,
I mean, I do.
I know you're laughing, but it is like an industry-wide problem. I mean, a lot of people, when they look at shingled roofs, they're not thinking is the felt damage, but the shingles are fine. No, I mean, it's an entirely different consideration process, and like for the roof covering, yeah, you have the water shedding capability. You might have UV protection, especially if you're in like a coated smooth roll mod bit or a gravel balsa EPDM or a built up. But I mean, you also like the substrate is really what provides a lot of the fire rating and the impact resistance and the thermal rating. So if you break up, and this is something like in the courses that I teach, like you break up each one of those attributes and you try to develop really black and white objective definitions for what's damage to this, what's damage to this attribute, this attribute, this attribute, and then go further into the components, and that's something that I think most people haven't really taken the time to think about. And I think I saw someone like, do you think Steve Badger's ever been on a roof? I'm sure he has, but it takes years to really understand each product, understand its intention, and something with like insulation is, I don't think people realize the financial like proportions of that part of the assembly. If you're putting on a new roof as a building owner, and let's say it's a retail job even, I mean, the thermal envelope, if it's all above deck and it's R30 and maybe there's a taper, I mean, that makes up a majority of the cost of that roof assembly, so
that's true.
Not the membrane. So I think there's a lot of like, just lack of understanding with how they're built and really breaking up each component. And obviously it shows. So,
yeah, if you think about, hail or something impacting a membrane and that energy departing through that material, even if the membrane doesn't get damaged, keep in mind, if you have a tear or a fracture in a paper facing polyiso, you just described a fracture to covered property. I don't know of an insurance policy that doesn't cover fractures to covered property. Forget about reduction of R value and loss of efficiency. The argument that Steve Badger made was that there was zero damage, period. And I think he knows better. I think that he's representing his clientele, which is why I do actually blame him on this. He knows better than to say there's no damage. That is a very different thing than to say that there's minuscule or negligent amount of damage. That's not right. Negligible.
At the same time, I think it's easy. And, I think we've all done this, like, especially those of us, that have worked just on this side of the industry. And like over time, of course I started out, in a public adjusting company, but like over time I started getting dragged into the defense side, even on, construction defect claims, whatever it would be, not necessarily even property insurance. And you really do realize like there's like a stigma on both sides. There's kind of this emotionally driven, interpretation of what damage is and what's owed under the policy and like ethical concerns. And like, for me, it's always been just very black and white. Like, is it damaged? Is it not? That said, like in something I talk about in the courses I teach, really, regardless of whether it's Xactimate or damage or code compliance, whatever it may be, is, like the reasonableness aspect of it. Because I know a lot of people, they'll try to get, an entire EPDM roof bought off like a bullet hole off a vandalism claim. And like, I think that those types of claims, you're going to reside in the more, is this reasonable? Is it unreasonable? And and it's more the emotional response type of claim, versus if you have, very straightforward damage. And you can see what I'm saying. There's a contrast there.
So for the audience's sake, there was a claim that I had it all good. That was a single bullet hole.
You got the reference, Matt.
And I sold that company to C3 Group that Andrew was working for. So I think that he's actually bringing up my bullet hole claim right now.
Was that you? Shoot.
Yeah, that was me. And to be fair, there was a lot more penetrations on that roof than that one single one. But the adjuster was not willing to write for anything except for that one for a bullet hole, even though I agreed with the adjuster on site that it probably wasn't even caused by a bullet because there was no bullet found in the insulation. It would have still been there because it didn't go all the way through the metal decking, and it wasn't there.
Yeah.
So that'd be crazy if it anyway. But it was that's a repairability argument. Mm-hmm. I knew we'd get into it.
Yeah, I mean that's
just a little bit longer on repairability because I've got someone else that I want to join us. And if you guys in the audience want to talk about repairability of single ply membranes during today's show, write something in the comments to let me know. Otherwise, we're going to stay to the outskirts of that. But if that's the path you want us to go down, let me know. Because there is a lot to talk about there, and we could fill up the rest of the whole session with that if we needed to. But as far as damage goes, and I think that's the first and foremost issue, we got to get coverages sometimes. And one of the biggest issues that we have is that the engineers that are sent out are often just saying that it's negligible damage to the R value, even though it's measurable. I like your approach to it. Black and white. Is it damaged? Is it not? The adjusters will say that to you, say, well, it either is or it isn't, but then they want to apply their own reasonability standards. Reasonability is a thing, though.
Yeah, and to that point, I mean, and I talk about this a lot. I know you've heard me say this, but like something that constantly kind of drives how I teach, and a lot of it's perspective based, because I mean, it's important. If you've never been in a deposition or been in an EUO or been in a trial, like juries are going to be weighing the reasonableness part of it. They're going to be, they are going to be emotionally making decisions. So, I mean, sometimes like, if you're even at the beginning of a process and you're ahead of like, hey, well, is this going to trigger someone's emotional response and be like, well, I feel bad for paying for this. It's like, you want to get ahead of that and you want to be aware that exists, that consideration exists. So
I never thought about it like that. Is it going to trigger an emotional response for feeling bad for paying for a roof? That's actually interesting.
Yeah.
How often does that happen?
I mean, I think that it happens all the time. I mean, you can't tell me like, especially on the claims like a bullet hole claim or, whatever kind of claim where the damage is less in extent. I mean, Pete, you're going to bring your own personal bias in, even you, Matt, or me. I mean, and it's something that I think we have to fight. And a lot of times, like, again, I try to train on just go back to the objective definition and set standards up, like what's reasonable to you, what's not, and I think if you ask yourself those questions before you get in a situation where the claim is literally driven by those considerations, then you'll be in better shape anyway. But
so what do you think is reasonable in a situation where substrate's damaged, membrane isn't, maybe there's no other damages whatsoever? Very rare situation, but in that situation, do you think it's reasonable to file a claim?
I mean, I'll give you an example. Like, let's say, you mentioned the bullet hole claim, but let's just go that route. Let's say a bullet hit a TPO membrane, indentated it permanently, and you had a
just a deflection in the membrane, didn't penetrate.
Yeah, deflection in the membrane, but underneath you had iso compression, polyiso compression, a facer fracture. You did a little core, and let's say this roof was 400 squares, and let's say
I want to buy that TPO, by the way. If it stops a bullet, that's some damn good TPO.
It's 60 mil fleece back, fully adhered.
Okay, actually, that might actually do it.
It might, yeah. If I remember anything from applying fire stuff.
Kevlar roof.
We installed that in your class, yeah. Remember that? Yeah,
that was KEE, I think. No, did we have a Kevlar roof?
Yeah, we did a fleece back TPO with Firestone.
No, we had the fleece back.
Yeah, that was not going anywhere.
No, that shit was crazy.
Claim, I mean, let's say it's a fully adhered system. One of the things that I've seen on some claims that had more extensive damage was you have the staggering of the joints of the cover board, the underlying insulation. If you have like a structural concrete deck, a lot of times you'll have systems adhere, or the layers adhere to each other, and not just the membrane over the substrate. So I mean, you do get into some staggering, but like, I will say, like, in that situation, yeah, I mean, I would kind of feel bad for like that one bullet hole. Could you repair it? Would it be exactly like on quality? No, but I mean, that's where, like, I imagine sitting in front of a jury and saying, we want this, $1.5 million roof claim paid for because of that, and just how that makes me feel. And that's something I think that naturally happens when damage is that limited, on that big of a scale of a roof.
Sure.
But
I feel like I need to qualify that bullet hole roof, though. You keep bringing it up as being so unreasonable. So for my audience's sake, this was not a very large, low slope roof. Mm-hmm. It was an old ass EPDM with a ton of patches that were already failing because it wasn't patchable at that point. So it wasn't really a repairable system, but it was small. I think honestly, it was maybe 35 squares.
Yeah.
So it doesn't sound as ridiculous suddenly when you're picturing something enormous. But I think every time you think of me, you think of really big things.
To that point, like, that claim that you were working, and this is something I remember being in a deposition, and we were talking about dense to metal roofing, and there was a cosmetic exclusion. There was a metallurgist, of course, the route. And the attorney that was opposing me said, what if it reduced the life by 1 day? Is that damage? What if it was 5 days? And she started from the other end. What if it reduced by 1 year? 6 months, 2 days. Well, and you could see what she was doing.
Yeah,
trying to narrow down and seeing what makes you feel bad versus what are you comfortable with, and really trying to dig into it. And of course, like, these are high pressure situations. You're being recorded. Sure. You're kind of on your feet, and that's why I think it's important to think of that type of range well before you get in a deposition. I
really want to do a poll now about that to see what people would think is a reasonable reduction in lifespan.
Yeah. And I think, like, and I know, Matt, like, in the class that I taught, the 5-day course, you wanted to sway away from the functional arguments, because it is, direct physical damage. Do you really have to say it's cosmetic functional? But I will say, I think when there are functional studies or studies revolving around functionality that quantify what that does to the product, I mean, it's kind of advantageous to use it. I think that,
sure.
If you can quantify it on a technical basis, you should,
I don't like to go down that path, mostly because it gets away from the policy. And as a public adjuster, my biggest strength is the policy. I can use that as a weapon against the carrier. If they're trying to use language that's outside of what the policy says, then I don't even want to go down that path most of the time. However, if there is clear functional damage, even the way that they're defining it, and you can prove that, that's a much easier argument than trying to say that you don't have to have it. So I don't know if it's really that necessary. I am getting a lot of people that are asking about repairability stuff, but there was one question here talking about other substrate, not just polyiso, but what about fiberboard substrates? What kind of damage occurs when you have hail damage to EPDM that's fully adhered to a fiberboard?
Yeah, so with adhered systems, it becomes quite a bit easier. I mean, in the sense that you don't have mechanical fasteners, except for the underlying substrate. So you're generally going to see square, plates holding down the wood or wood fiberboard substrate. So the membrane is held down by adhesive. So that's the bond between the membrane and the fiberboard substrate. So if you have a hail impact that depresses that, and it's with fiberboard, it's hard to tell. And I'll say like you have to look at many fiberboard destructive testing areas and pull it back. And what I recommend is, if you have an opportunity, even if you're on a roof that, you don't think is necessarily damaged, but you have a roofer on site that can repair it, the building owner is okay with testing it. I mean, the more exposure you have, especially to the fiberboard products, the better. Perlite products, the newer ones, actually exhibit in a very similar way. Johns Manville has one that's kind of a newer product that exhibits similarly. And what I mean by that is you might install a brand new TPO, EPDM, any kind of single ply roof to a fiberboard. And if you do a 2x2 flat back, when it's brand new, you're still going to see some of the fibers pull off with the membrane, some say on the substrate. But what I've seen happen is a lot of people will know a hail event occurred. They feel maybe some irregularities, really not knowing that the product by itself right out of the factory is very irregular. And they're not
Even
used to
polyiso has those striations in it directly from the factory, and it does confuse a lot of people.
Yeah. And it really depends on the product. I mean, different manufacturers will exhibit different ways. So, I mean, you really have to be exposed to the products and how they exhibit right out of the factory before you can even claim that you know what the damage looks like in the field. But, I mean, when I pull that back and just to walk through it, those of you who aren't really familiar, generally, like, you'll want to do a test area before you do the flat back. And the reason for that is if you think you feel things and you pull back the membrane, and you look, you're going to associate things. And unless you go through a really defined process, it's not going to be very scientific, and if someone else reviews that, and, I'm obviously speaking out of like a very technically driven process,
that's what we all should be striving for.
Which some adjusters,
what is your process? What are you saying? You do a core sample first before you peel back the membrane?
So of course you're going to want to make sure, if we're talking about hail losses, make sure the collateral supports it, weather data supports it, are there past events? Were there 10 hailstorms? These are things that you want to look at on any loss. But I mean, assuming that there's been sizable hail that impacted the property, generally what I'll do is I'll look for spatter marks on the membrane, the topmost surface. If there's oxidation, obviously on like TPO membranes, you're not going to see that as much, or any kind of white or off-white product. But sometimes you get dirt accrual or debris that kind of gathers over time. So if you see spatter marks, essentially you're going to do a test area. Generally what I do is a 2x2, which is 1/25th of a square. So it's not a full 10x10. You're not going to want to, flat back a 10x10 piece of the roofing membrane, but you basically mark out that test area. You can see where hopefully spatter marks occurred. If not, you're still going to run your finger across that substrate and just try to identify depressions, any kind of abnormalities, fastener plates. And it takes a lot of time to be like, oh, this is a fastener plate. Oh, this is overdriven. This is underdriven.
You ever thought about going to like a, I don't know what kind of facility you'd find them at, but hiring blind people that can read Braille? I bet they would be able to find hail damage under a membrane.
Yeah. I mean, and honestly, like maybe it's not a bad idea. Close your eyes, feel it, because you will do funny things when you're looking and you're feeling and you're pulling back and your end goal is to get the roof bought on this side of the industry. You're going to look like an idiot, so you have to go through a really defined process. But yeah, I mean, if you feel an indentation that corresponds with the spatter, you're already kind of going through a process of like, you're attributing that to this, you identify it before you even cut it. And then you're quantifying, all right, let's say I have 15 depressions. I think this one's a fastener plate, so I'm going to put an F on the membrane, whatever your process is. But then when you cut that back, let's say it's a wood fiberboard adhered EPDM over that. When you're pulling it back, you're just kind of looking, and fiberboard, you have to be a little more careful. Any adhered system, because you're going to be pulling apart some of the product of the underlying substrate. So you're going to be pulling apart wood fibers, and sometimes like you need to pull it fast. Sometimes you go slow, really depending on what happens, because you think of like a tablecloth, you pull it off, the glasses stay there. Sometimes pulling it slow, you're going to destroy the substrate, and you really have to kind of change how you're approaching that.
I've never pulled a membrane back fast.
Yeah. And
That's
it just
something I
depends.
never thought about.
I mean, I'll get back to that kind of line of thinking, but some modified bitumen systems, like, you're gonna have torch down, you're gonna have hot mopped, you're gonna have peel and stick, cap sheets, and a lot of times if you're trying to separate the cap and the base sheet, many times it's gonna be so well bonded, especially if it's like a hot mopped product, you're just gonna destroy the base sheet. You're not gonna be able to find star fracturing. If it's torch down, there's going to be little areas where, there's not going to be as good of adhesion between the base sheet and the cap sheet. So, and that's the thing. It's a variable process, and you can kind of deviate if you're realizing I'm destroying the evidence. What else could I do? Like, stop, slow down, like, just think about it. But yeah, I mean, on that product, that scenario of EPDM fiberboard, it's adhered. You're pulling that back, and essentially what you're doing is looking for a correspondence then from the marks on the top side of the membrane to the substrate and how it exhibits. So fiberboards are tricky. I've only really run into maybe 3 instances where there was sizable hail enough to permanently depress the wood fibers, and I'm talking about 1/2 inch indents. And at that point, I'm just quantifying, hey, this is clearly an indentation. I have a straight edge.
1/2 inch is pretty significant.
Yeah, and I'm talking about the indentation, not necessarily the hail. I mean, that.
Are you talking about the diameter of the indentation or the depth?
So depth, and that's something with
1/2 inch depth is significant for fiberboard, dude. That must have been monsters.
Yeah, this was a May 8th, 2017 storm. Those of you who knew that storm in Colorado, so the Golden area, it was 2.5, 3 inch hail, huge. But it shows you how resilient, for one, EPDM was, because there were no fractures. But you have a very rigid substrate adhered, and the problem with the fiberboard products is they're not faced. So generally they're going to be primed to accept the adhesive, but it's just a bunch of wood pulp and glue. I mean, that's a lot of resilient product, and you have a lot of independent wood fibers that can really kind of rebound after they've been impacted. Versus
on that adhesive though, does the impact from the hail cause the adhesion to fail at the impact zone?
So generally what I've found is if hail sizable enough to permanently depress the substrate, now, essentially you think of basically the membrane and the substrate are flush. It depresses, the membrane recovers, and the substrate does not, and that's really the condition you're looking for is the substrate separated from that. And you can tell generally by, you felt it, you went through a very defined process. And then when you pull it back, you can see that depression. You can see that there was a void there. And if they were still attached, you would have seen a depression on the EPDM or the single ply membrane. So
on that indentation that you had, a 1/2 inch depth, did it broadcast all the way through to the bottom side of the fiberboard as well? Did it break apart like you do on like dense deck or something along those lines?
So that's a great question. So no, on that case, I have run across, this was actually, it was also a May 8th storm. It was TPO. I think it was 60 mil mechanically fastened over DINS deck, and it was a 1/4 inch of DINS deck over EPS. And it was actually a tapered EPS system, expanded polystyrene, over a wood deck. So all mechanically fastened, and hail hit these locations, didn't compromise the TPO at all. But the DINS deck was, we basically had fractures this big around, about 2.5 inches across. And on the backside, there was actually spider fracturing where the DINS deck had fractured as well. So both facers on both sides of the DINS deck were fractured. And this was actually a Secure Rock product, so it was USG, not DINS deck, very similar. Yeah, I think a big thing with substrate is, like with ISO and DINS deck, I mean, you kind of have like the product is very monolithic almost, in a sense, where you have kind of, foam that's cured and it's all connected and there's really not much give. If you try to break it, it's going to snap, If you try to bend a wood fiberboard, there's going to be a lot of flexibility because you have a bunch of independent wood fibers. So, and again, I'm just kind of theorizing this and how that works.
That makes sense.
Yeah. I mean, I think when you are in the field a lot and you get a core, what I recommend doing is when you core, pull out each of the components and feel them, like compress them, and you can kind of get a good gauge for, all right, like this makes sense. Hail could cause this condition, and you learn a lot just by exposure of when you do a core. You might as well core and get familiar with the products. So
Patrick asks to further go into the loss of adhesion. He says on EPDM, how would that affect the longevity or quality of the product?
So again, we have to think about extent here. I've seen somewhere in a 2x2, you have 47 areas of facer fractures or adhesion loss. And on an adhered system, that's pretty extensive, and there are lots of engineering studies out there that talk about single ply membrane roof assemblies can fail in extreme wind events if they have facer sheet compression or facer sheet fractures, or insulation compression. So yeah, I think the answer is obviously really contingent upon the extent of damage. If you have one impact in a square, you're not going to have much as far as like uplift resistance likely. But there's other arguments, and obviously we go back into the reasonableness part of it, and kind of weighing that. But yeah, generally with adhered systems, you're going to have, with extensive damage, you're going to have, it's going to be prone to uplift damage, uplift resistance. It's not what it was. And there's a lot of engineering studies that support that.
Yeah, that's a good question.
Yeah, very good question.
From a wind standpoint, with a fully adhered system, you could end up with a billowing situation, or where air gets between the membrane and the substrate and allows it to rip apart that adhesion. How do you tell a difference between tenting at a parapet wall roof junction and wind caused billowing?
Yeah, so generally you're gonna, let's say we're talking about an adhered system. So on the perimeter, generally you're gonna see, over age, you're gonna see some tenting of the materials. But I'll kind of start in the center. So what Matt was talking about.
Maybe we should define tenting. I just realized how very specific that is. Do you want to define tenting real quick?
Yeah, so essentially tenting is going to be like, especially on the parapet walls, this is a very common kind of concept where over time you're going to see it a lot with the older EPDMs where, let's say it's a ballasted EPDM, you're going to see this a lot where you have river rock all across the system. It's a loose laid membrane across the field. And usually it's going to be adhered at the perimeter parapets. So you have loose laid membrane attaching to an adhered vertical transition with EPDM. And usually on the transitions, it's going to be adhered right over the plywood or OSB, sometimes concrete, masonry, whatever it is. And a lot of times over time, especially with the older EPDMs, they contract, So when that happens, it's going to pull that away from the parapet wall. And what ends up happening is it pulls it completely away, and you have a void where essentially you don't have a 90-degree transition. It's essentially just going to be, diagonal with the roof. So you're going to notice, tenting there. Wind can cause tenting though. So even something with that is, what I used to do a lot is generally when you have aggregate roof systems like a ballasted EPDM or even a built up, and you're thinking maybe this is wind damage. A lot of times if it's pretty recent, you're going to have a rock line, like an aggregate line somewhere along the base of that parapet. And if it was recent,
where the dirt of the rocks shows that that's where the line used to be. So you can see where the rocks used to be just in the dirt line.
Yeah. And if the rock's been sitting there for, let's say 10, 20 years, 15 years, whatever it is, you're going to have fade rates differ from what was exposed EPDM on the parapet versus the field that was covered in rock. So if that was recent, you should see some differential there between, fade, and you hopefully should see that aggregate line. And if not, which many cases I've seen a lot of EPDMs where it's like, that's been tenting for probably 10 years, 20 years, but just those little indications that like, pay attention, just think about it. Like, does this make sense? Because if there's an engineer, they're going to be looking at that stuff. But how do you tell the difference?
It's difficult at times to really show that it was not just your natural, I'll call it wear and tear. Tenting is a portion of wear and tear, something that occurs naturally over time.
Yeah.
But there's so many ways that air can get behind the system, especially at that junction.
Yeah. And the wind damage I've seen, especially like here in Colorado, we have wind events quite often that, the wind come off the mountains. And you have a lot of downbursts, and, we've had winds continuously. December of 2021, there were like 120 mile per hour sustained winds for like, it was like 8 hours or something like that. Wow. But generally, if you have, edge damage from wind, you're going to see a lot of dislodged coping metal, cap flashing. But you may see some dislodged membrane, but you're just looking for those indications of recency. So what was that?
Recency. I don't know if I've heard that term used like that before.
Recency, really? Well, here we are.
It might be a word.
Yeah, but to your point, like in the field, Matt was talking about how wind pressures can basically billow up the membrane. So let's say just the scenario, we have a mechanically fastened substrate. So think ISO, it's maybe staggered and it's mechanically fastened through a steel deck. It's corrugated, and then you have a adhered membrane over that. Those of you know, like an airplane flies or any kind of wind principles, essentially when you have airflow over a building at a high velocity, it's going to increase in velocity as it travels over the building, and it makes a pressure differential. So you have high pressure inside the building, low pressure areas where the wind is, increasing in velocity over the structures. So it's creating an uplift force on that where the pressures are trying to basically reach an equilibrium. And you have wind, or air pressure rather, that goes through the joints of the ISO and causes the membrane to uplift. So if that exceeds the uplift resistance of the membrane, it's going to billow. So I would say a sign with that, and something you see a lot of on the, I wouldn't even say it's a defect. It's very common with adhered membranes. They're rolling it out, they're brushing or they're spraying, rolling the adhesives, and you're going to get little wrinkles. You're going to get imperfections of the membrane where it's raised, but it's perfectly adhered on both sides. And I'm talking like a ½ inch.
Right.
Ripple, and people like wind damage. No, you'd expect to see billowing wind damage on a membrane at the seams of the substrate, and you're going to see adhesion loss. So in those areas, do a destructive test. Do a 2x2, do a 5x1, whatever you need to do to get from an area where it's adhered to where it's unadhered. And if you're running into things like facer, basically separation from the substrate, and it was once adhered, you're probably more looking at a wind event versus an installation issue or things like that, or a wear and tear issue. But I'm pretty confident that, like, with the right destructive testing and really just understanding the principles of that you can differentiate between the two if you just take enough steps. And if you still don't know, you probably could go more steps and figure it out one way or another.
Remind me to come back to destructive testing. So Josh White Killer, we're not going to talk about his name. Have you ever seen wind damage to a mechanically attached roof without edge metal or coping built back?
So he's referring to, have you ever seen wind damage without the coping or edge metal being damaged?
I don't know what he means by the build back portion of that question, but yeah.
I'm assuming
if you don't have the edge metal or coping, have you seen wind damage to a mechanically attached roof at that point?
Yeah. So, So if you understand the principle I just discussed,
callback.
Really the biggest or highest level or uplift from that airflow over the structure, it's going to happen on the roof edges. So sometimes you're going to have that uplift cause more pressure on the membrane where it doesn't quite dislodge the coping metal or cap flashing. And then you get into a whole other situations where, does it have a cleat or not? Is the edge metal properly attached? Was it designed with a cleat to where it had more uplift resistance, where it maybe wouldn't fail before the membrane failed? There's a lot of considerations there. So, I don't think that I could say absolute one way or the other, but I will say, like, I've seen both. And I think a lot of it depends on how well the edge metal is attached, because you see varying methods there. So yeah, that's a big thing. And age too. If you have an aged roof, the membrane is going to fail likely well before the edge metal if it's attached with a cleat at the parapet wall. So yeah, lots of variables there.
Yeah, there are. And then I got Anthony Hines. Which low slope roof systems are most likely to fail against strong wind?
So roof systems. So I would say adhered systems likely, especially if they're aged. You got to think with mechanical fasteners. You have areas where the membrane will billow a little bit. It's going to have some give to it, versus with an adhered system, it is flush with that membrane or the substrate. So if it starts to go, it's going to go. Versus, with a mechanically fastened system, it might fail, but then it's going to hit that next mechanical fastener course over. And it's kind of a fresh start to, all right, is it going to domino or is it going to stop at that next course over? But an adhered system, once you break that adhesion and it starts billowing, you get more and more uplift resistance, and it's going to carry it. And that's why, I've seen a lot of roofs like modified bitumens or roofs that had adhered cap sheets or, things like that same principle, where once they start ballooning, that whole roof goes, and that's, I don't know if you've seen that map before. I don't know if you've worked a lot of wind losses.
Oh, I have. I end up seeing more wind losses to low slope than hail, to be honest. But I don't live in Texas or Oklahoma, or Colorado for that matter. So we get a lot more wind. I have noticed that on low slope systems that have very thick foam insulation of some kind. Maybe it's, your yellow death or your polyiso.
Yellow
If
death.
it's real thick, the yellow death is terrible.
Yeah, it is.
It gets all over you. You
Those
have
of you
a
know,
really
hey, you
long
should probably tell people what
fasteners on a
yellow death
mechanically
is.
attached system. The thicker the insulation, what do you say?
I said you should tell people what yellow death is. It's rigid fiberglass insulation.
It's fiberglass rigid insulation, and it's
yellow death.
it's called yellow death for a reason. It itches like a mother. It's terrible.
Yes, it is.
And it's also a respiratory issue. You don't really want to cut into that with a circular saw, which you might do if it's in a built-up system. Anyway, if you have a lot of insulation, something soft like foam insulation, you have to mechanically attach single-ply system on top of that. You've got some long-ass screws, and they're very thin. They're a quarter inch or so, maybe. They're a quarter inch. They're 2/8. They're 1/4 inch thick. The longer it gets, the more torque you have at the top.
Yep.
And wind can easily bend that kind of a system. So I find that on the systems that have very thick, soft insulation or softer substrates, it's a little bit easier to get wind damage on a mechanically fastened system.
Yeah, it makes total sense.
Yeah. I think that surprisingly, we have a lot of people watching and very few actual questions. It's kind of blowing my mind. I think that you're just blowing everyone's minds right now.
Oh, well, I have an interesting scenario I can talk about, I think, maybe.
Let's do that.
This was an interesting claim. I think it was 2016, maybe. No, it's probably 2018. It was a tornado loss. Essentially, a tornado went over the property. Part was severely damaged. Trusses dislodged. Lots and lots of damage. I mean, it was extensive. But this one building had a adhered TPO system over dense deck, and then ISO beneath that, and then there was a built up beneath that. So it was a second roof recover system. And essentially what happened was the membrane in some areas was punctured on maybe 10 or 15% of the roof. This rooftop unit dislodged, punctured, the panels dislodged, and punctured the TPO all over the place. So it absorbed a lot of water infiltration. And essentially I had a Tramex, so I'm like, all right, let's see where the water is. And it was obviously 10 to 15% of the roof on one side. We know it's a roof recover. We don't allow more than 2 layers per code, but it is important to know that they have two layers. Something important with 2 layers that I'll just kind of throw out there: if you have water infiltration and if they have a second roof layer, a lot of times you're not going to get water infiltration to the interior, because if you think, like, I've done cores where there's standing water. Yeah, of an inch, so it offers a lot of, especially with asphaltic products, because it's really a vapor barrier of sorts, or vapor retarder. So, I mean, you can have standing water there where it doesn't migrate inside the system. So, just because the building,
unless you're putting a fastener through it.
Yeah. And even that, I mean, asphalt products are very, they seal, there's a lot of,
I don't know. Yeah. I've had a different experience than what you're describing, to be honest, though. A lot of the layovers or roof overs that I've experienced that have a built-up roof inside of it, they're leaking like crazy.
And some, they remove so that's a great point. I'm glad you brought it up, because some roof recovers, they take off the perimeter flashing, the curb flashing, the transition flashing. They'll cut it because they might need to run new product against the parapet wall. Sometimes they leave that in place. So you can imagine, like, you have more of a barrier if you leave those in place versus not. There's a lot of curbs on commercial roofs.
I mean, yeah, we've experienced a lot of water infiltration in the middle of the field as well, not necessarily at the edge. But I haven't even thought to look for that situation, to be honest. So
so in this case, it was interesting because it was a TPO overlay, and what gave it away for me was there was a termination bar under the rooftop unit, and right behind the termination bar where there was caulking, which is kind of a telltale sign it was a roof recover when you see term bar, because usually on the mod bit system originally ran it up and over the curb. So you could see the granulated flashing at the curb, so you kind of knew how they left the flashing in place. But essentially the water, even with the Tramex readings, had soaked the Dens deck or some of the underlying substrate. Obviously, I couldn't tell before cutting it. So I did 2 tests, one on the dry side, one on the wet side. Dens deck was essentially like a wet powder. If you imagine wet drywall, just paste.
It's drywall. Yeah.
And essentially, like, if we understand commercial roof assemblies, we know that the membrane is adhered to the substrate, which was Dens deck, and the Dens deck was mechanically fastened to the ISO. The issue here was you couldn't just cut randomly across the TPO because you have staggered joints. So if you want to maintain the staggering of the joints, which is a IEC requirement, actually, the ICC requires staggered joints and more than 2 layers. So in this case, like you pull back the membrane so far and you have a staggered joint, you pull to the next joint and you have another staggered joint. So with adhered systems, it's much more challenging for repairability. If it was a mechanically fastened system, theoretically, you could pull it back, maybe cut.
Yeah, you can make like a wider at the top, narrower at the bottom kind of repair.
But I mean, it's just,
you add that adhesive in there, you're damaging materials as you're tearing it up, so it doesn't matter.
Yep. Roof vents are a dead giveaway. That's 2 layers. So I think what he's referring to is vapor vents. So you have 1-way, 2-way vapor vents. And they usually like kind of common on PVC, TPO with a little like a
little hat
PVC
on
cap.
On
built ups, you see them a lot. They're aluminum and they dent really easy, but they have this little cap on the top. I will say though, if you look at some of the Duralast specs, they actually specify these be installed on some systems, even if there's 1 layer. So I agree with Michael, and actually like I would say 99% of the time that's a roof recover.
and it doesn't dry out the systems fully. There's plenty of documentation on that, but it is a good indicator that you have multiple layers. Although the Venturi vents, I haven't seen any documentation on whether or not those are successful at drying out the systems. I haven't actually come across any though either.
Yeah, me either. Not that common. You know, that's the funny thing is like some of the systems, I mean, you hear of like the Velcro systems or the hook and loop systems.
Right.
I've never seen that. And it sounds like a terrible system.
Right.
I've heard actually quite a few issues with them. With just, you know, you get products that are supposed to be easier, but they get more complicated on the manufacturing side. And I've heard a lot of issues where the adhesive between the membrane and the hooks fail, you know, and I mean, it's a lot of those systems you don't see a lot. So,
you know, it acts more like a fleece fix system. So I challenged my audience to come up with questions and they delivered. Now I have too many probably. So I'm going to start from the top here. Actually, no, I'm not doing this one. Nick, I'm sorry. We don't have time to get into repairability. I will make that a completely separate topic. Chad Williams, one of my absolute favorite engineers, is sitting in the wings waiting for this topic, wishing I would pull him on to talk about it. He looks very disappointed right now. I know you can't see him, but that is going to be a completely separate topic. I'm sorry. It's a full hour's topic. It really is. I don't want to do it in injustice. So I'm sorry, I'm not doing it. Coming back to you later. All right. In your opinion, from Kevin Hubbersland, although with an O like that, does that change how it's pronounced? Hubbersland? I don't know. In your opinion, is mechanically fastened or fully adhered better on taller buildings? I would assume you'd have a lot more wind on a taller building because it's higher at elevation.
Yeah, I mean, again, so many variables. I mean, you're going to run into structural concrete decks, lightweight, you know, concrete decks. You're running steel decks, wood decks. I mean, so I think a lot of the substrate matters here. Are we talking about mechanically fastened membranes, or are we talking about the substrate? I would say, in my experience, though, I would say mechanically fastened from what I've seen, and that's kind of just a guess. And I mean, I have some limits on the wind damage side. I've seen tornado claims. I've seen a lot of hurricane claims. Not a lot on the flat roof side, though. A lot of what I do is hail, fire. Wind's been kind of more the limited side of my experience, to be honest. But I would say mechanically fastened for kind of the reason we just talked about, where if it does fail, you have a bunch of backstops where you have additional fastener courses, you know, versus adhered. When it goes, it's going to go. So I don't know if you agree with that, Matt, but that's kind of my take.
I think that's good logic. You know, ultimately, when you have a tall building, if the membrane does open and you start getting water inside, there's a lot more structure for it to damage. You want to be very careful with it. So I would imagine you have to. The taller the building, the stronger the wind forces are going to be for that building. The wind load is going to have to be designed higher.
I will say
there are definitely papers on that.
Yep, there's a good point. I've seen hybrid systems too, where it's mechanically fastened EPDM over substrate, and then about 8 to 10 feet from the edge, they'll adhere it. So you do see that, and sometimes you see them just mechanically fastened as well as adhere. So you're going to see combinations of things on the design side. But I've seen that mainly because the uplift resistance needs to be more on the roof edges. So you're going to see things like that on the design side.
I think that's true.
yeah. So,
All right. What is a clear indicator a low slope wind claim would be a full replacement, possibly even roof deck replacement? Clear indicators.
clear indicators, moisture. I will say on decking, like, and this is the approach that, I know there may be differing opinions on this, but for me, if I go to the bottom side of the steel roof deck and it has a little bit of surface rust, I'm not putting in to redeck the entire commercial property,
What?
Wow.
But it's
I've seen it so
clearly
many times.
damaged.
I think when we're talking about decking, like make a note, have a conversation, put a pending note in Xactimate, whatever.
Mhm.
Don't represent a cut. Like, just don't scare them. Like, come on. Like, one of the things in the class too is like you have theory and you have knowns. Like if you can verify the known and you can, ensure that there's coverage for it, go with the known. Don't.
What if there's one area of rust on your steel deck that clearly is a result of a penetration in the roof structure?
I've done allowances before. So what I've done is I've approximated an area, but like 10% and the remaining 90 is pending, and just have that conversation. But I like to be kind of conservative there because there's going to be a lot of unknowns when you tear off a roof. And some things, if you can't see it, don't throw in the kitchen sink, and assume it's there. It doesn't work. But
all right, what if the carrier sends out their own contractor to verify moisture readings that you've provided to them, and that contractor brings out a Sawzall, and he just goes at that roof and tears holes in the metal roof deck?
That's a problem. Have you run into that before? That's terrible.
Yes, I have. More than once, actually. I love inviting the carrier to send out a contractor of their choice. Very often we find that the contractors that the carrier send out are a lot less careful than the contractors hired by the policyholder, mostly because the contractors hired by the policyholder are terrified of being accused of vandalism. And the contractors hired by the carrier just don't give a shit. They don't care.
I think what's funny is, when you have people coring roofs for the first time, like I've had people try to core a roof with a butter knife, like it's pretty bad. So buy the right tool. But it's funny when people assume it's there was a guy that scooped out the core with a spoon. Ask Sean O'Malley with C3. He'll know.
Wow.
Pretty bad. But when people core a roof and they assume they're going to hit a solid deck surface like a steel deck or a wood deck, and they go through the gypsum deck and the form board, and they see fluorescent light come through from the building.
Freak them out.
Come on.
Yeah.
But yeah, the last question though, moisture for sure.
Moisture is really the key for a lot of these to go for a full replacement. You got to be able to track the moisture under the membrane. That's going to require some specific tools and some specific training. And I'm sure Andrew goes into moisture mapping and all that fun stuff in your class, right?
Yep, for sure. And just
go.
quantify, based on substrate type too, because that's huge.
There you go. By the way, I've taken a class from Andrew in the past. He presented one at National Claims Institute while I was there, and it was fantastic. And it was 5 days long. And you're doing a shorter version of that class now in April. Yep. And at the end of this show, I'll give you guys a coupon code to get into his class cheaper. He doesn't know that I'm doing that yet. Poor guy.
All right, fine.
I might bully him into giving you guys a coupon. All right, Patrick asks, since you dared me, what about the possibility of condensation formation in the gaps where a fully adhered system was struck by hail and a permanent indentation exists in the fiberboard?
So I'm assuming he's talking about where that void is, where there could be condensation.
So when there's a void created, it does allow air to fill that gap. It's going to create a little vacuum that's going to pull air, which always pulls some moisture in there. So go from there.
Sure. Yeah. So in the class that I instruct, we talk about dew point. A lot of people don't even know what dew point is. But a lot of that really depends on, the climate. As soon as you hit dew point, it's the temperature in which the ambient air saturates or can't hold more moisture. And that temperature is variable. So you're always going to have some level of moisture in the air. I personally have not seen, it's an interesting question, but I have not seen areas where that little air pocket is more likely to condense, because all the air in that system should, in theory, have the same, humidity and same moisture content. It is a good topic though, when we're talking about built-ups getting wet or the substrate getting wet, and how that moisture affects like interplies or any kind of system where moisture can, it can evaporate, it'll condense elsewhere in the system. And you can have migration where it's not just water in one part of the roof system, you're increasing the humidity within that system, especially if water or if the vapor can't flow or if there's no airflow within the system, which is limited anyway, as we talked about with vapor vents. But there's a really cool study going back, I think it was like 1952, and it was from the University of Minnesota, and it talks about how you have like a 1/16 of an ounce of liquid in a cubic space, a cubic foot area of space, and essentially it doubles the exerted pressure just by a 1/16 of an ounce of liquid in that. So moisture is a big deal, especially with built-ups, mob bit. But that has to be an enclosed space, you know, so we're not talking about a metal deck and a membrane. I mean, really the membrane is the only vapor barrier there, unless you have some other form of a vapor barrier or vapor retarder. So really, I mean, the varying pressures can dissipate in and out of the system. But it really depends on the climate, in my opinion.
It's also going to depend on if you have enough insulation in the system as well. You know, if there is thermal exchange or that's probably not the right term, heat exchange between the inside air and the outside air, you're gonna end up having condensation build up somewhere, and it could definitely build up in that little area. But if you have the proper amount of insulation above roof deck, then you probably won't have too many issues with that. It could still occur if there is a difference in temperature just below the membrane, but there probably isn't going to be that much of a difference in temperature there.
Yeah. And really it's understanding like where the dew point occurs on the roof. You know, if it's 70 degrees outside, or let's say it's 70 degrees inside and it's 15 degrees outside, I mean, the dew point's going to be somewhere in that system.
Right.
And if you're in a humid climate, you know, you don't want that moist, warm air of the interior to migrate to a dew point within the roof. You want to stop that through a vapor retarder so that humidity doesn't make its way up and touch a dew point. So yeah, it's complicated, but
that's not a question. Get insurance to pay for emergency coating before the replacement. I remember why I started this. This is an interesting statement. Now, Mike Feinberg says, get insurance to pay for emergency coating before the replacement. So if you have a full replacement that's being paid for, he's saying that you should get them to pay for a coating. And I would assume that would be like an acrylic or a silicone type coating or something along those lines, hydrostop. And this is very useful if there isn't availability of materials, as there hasn't been very much of polyiso and things along those lines lately. How do you feel about this though, Andrew? I know what I feel about it.
Yeah, I mean, I think it's way overused, just like shrink wrapping. You know, I think people take it too far too. Like they'll go the coating route and they'll mitigate, but they'll literally install like a coating as if it was meant to be a standalone coating for a permanent solution.
Right.
You know, and like if you look at, I just did a project, it was a defect claim, but it was a Geico product. And if you look at the specs for like the Geico S2000 product, it's a lot. You reinforce the seams, you know, there's a lot of different specs you have to follow. You have to use bleed coat, primer, you know, and you have to follow dry film thickness requirements. Like it's a lot. So I think when someone installs like that type of spec for a temporary solution, you know, I think that's kind of unreasonable. I would bet that a lot of times if you just installed, you know, a minimal amount of coating, and of course it depends on how long you need it to last, and you're gonna have to weigh that, but you don't need to install it as if it's a system just to get 100K, you know, juiced out of a claim. I mean, that just doesn't make sense. So,
and it is a system now. The building code does designate coatings as its own system, depending on the type of coating that it is. So it can be a roof over. It can count as a roof layer.
For sure.
Which is important to note, because if you have more than 2 layers and there is saturation, you've got a problem, right? Well, if you have saturation, there's always a problem.
What's your take on that, Matt? Like emergency coatings, though, before
so I'm following along the lines as you are. You know, when the materials are impossible to get, I know that there were a lot of contractors that felt like they were stuck between a rock and a hard place. They didn't really want to necessarily do this, but they felt like they were obligated. And they know they caused additional issues because it traps the moisture in the system. You're not allowing it to get out. A lot of coatings don't put little vents in there. You're not going to have a lot of escape of that moisture. There's really no way for it to go out upward. It's going to have to come out inward. So you're trapping that moisture and allowing it to find its way into the interior. But if you can't get the materials, you can't get the materials. So in those situations, I think there are cases where it makes sense. Not a huge fan of it overall. I want to find ways to avoid it if we could. Yeah, I feel about the same as you do on that.
Yeah.
All right, we've only got like 3 questions left. We've already gone over time, but I'm going to at least get these 3 questions done. Anthony asks, with low slope roofing systems, how common, if any, do you come across discontinued products?
I would say, in my experience, not that common. I would say, one of the ones that I can think of happening, and honestly, like these are the things that I never hit on a technical level, just because there were other ways that were, a more direct route to get replacement, like through substantiation that was actually factual versus going that route. But I can say, like I've seen like Genflex TPOs that were fracturing; they almost exhibited like PVC, the plasticide, something in that. And I think it was their products were pretty bad, the first Genflex TPO products. But I mean, if you're trying to heat weld a new TPO to a very old, I guess, discontinued, you could call it. But I mean, a lot of it could just be age, it could be deterioration, lack of ability to heat weld to that product. So it's more of those types of scenarios. It's never been like, hey, this is this product and it's not made anymore, so we can't do this. I haven't run into that on the commercial low slope side.
I mean, I can tell you this. There are definitely obsolete products. It might have the same brand name, might have the same model name that it's had for years, but TPO has not been the same chemical composition over the years. Yep. It has changed many times and been updated and had different polymers added to it. So whether or not you can weld new TPO with its current chemical composition and older TPO with its older outdated composition and have the same kind of yeah, I mean, there's a lot of issues there, but there isn't any good research that we've been able to come across. This is the kind of stuff we're going to get into in the repairability talk, though. So I'm moving on. That's a really good topic. I can't wait to get to Chad in here to talk about that shit. He's just sitting in the wings, just wishing, and I'm just ignoring him. It's great. Poor guy. Michael Feinberg, what makes the screws push back? That must have been something we were talking about earlier.
Yeah, I'm not really sure. I mean, he might be talking about
that might have been what I was talking about with the wind pulling. So you are going to have uplift, and if you do have uplift, there's usually a lateral force of the wind going across, and it will actually lift and pull along its route. That's part of Bernoulli effect. So it will actually pull the screws, and if they're long enough to where you have enough torque at the top, it will actually bend the screws if the substrate is soft enough, and then you'll have a bent screw. Yeah. And then it's pulling away from the edge, so you're going to end up with a lot of billowing and things. Usually a parapet.
I mean, if you think like a torque wrench, the longer it is, the more force it has at that rotating end. So
I think that's what he was asking.
Yeah, I think so.
All right, last one, and this is from an IA, April M, my favorite IA that ever watches this show. I don't know why some IAs watch this show, but April's awesome. I found that low slope roofs, especially those with zero slope, often will have a lot of damage to the ceilings and attics, more widespread because most times, since it's flat, you can't see that there's damage unless you happen to get up there for whatever reason. This unknown time from beginning till discovery with no slope has allowed lots of water to collect with nowhere to go but everywhere. That's not a question. But you want to comment on that?
Yeah, I mean, I think first off, like I've seen properties that had sheathing from the 30s, from the 20s, where they've been re-roofed several times, but they exhibited the same way. Like they were stained, they were, some areas of decay. You can't necessarily use that on the underside as an indication as to the roof system that's installed over the top. And that's where like you really have to approach from both sides, like do destructive testing, look from the underneath. And you're going to see some alignment there as far as findings go, or completely opposite findings where you're like, okay, like that makes sense or whatever. But yeah, I mean, interesting question because it just kind of prompts an observation I had on this one claim. It was a wind damage claim, and there was water saturation and staining on the underside of the deck. I remember one of the carrier engineers went out and they were basically stating that the staining was due to long-term deterioration and water infiltration and failure of the roof covering, wear and tear, et cetera, et cetera. Mm-hmm. I went over there and I found a couple areas where it was brand new sheathing installed over the roof joists. Well, you can't install sheathing without going top down. You can't slide a sheathing panel in between the roof and the roof joist. So it kind of showed that sheathing in that condition was from probably like 2 or 3 roofs ago. I mean, this structure was built in like the 20s. So it's just kind of funny. I mean, that's where you really have to go bottom up, top down, cross-reference. But yeah, I mean, as far as the slope goes, yeah, I mean, if you have no slope, you're gonna have issues, especially as the roof ages. So yeah, that kind of goes without saying. But yeah, I don't know if you have a comment, Matt. But.
I mean, I've had similar experience. I can think of one in particular where there was a honestly, this is a very important claim to me because I got the roof paid for improper installation.
Mm-hmm.
As an ensuing loss. And I've got videos on ensuing loss where I talk about this particular roof, but this roof was built up with a mod bit that was built on top of it with OSB used as a cover board on top of the gravel mod bit. But there was water penetration into the entire system, and every room inside this doctor's office, every single room had stains covering their ceilings. I mean, it literally was everywhere. And it had a lot to do with the fact that they installed a mod bit on top of it very, very poorly. And the water found its way to the interior, following the path of the fasteners into the substrate of the built up roof, and that just saturated everything. But anyway, it has been an hour and 10 minutes. We went over because this was an important topic. Andrew, tell me about your class real quick.
Yeah, so I'm doing it April 3rd, 4th, and 5th in person, Castle Rock, Colorado, downtown. Really cool venue and stuff. But essentially, we're talking about damage assessment, code compliance, a lot of estimation considerations with Xactimate. And then I'm actually including, so I already do Xactimate classes, and I'm providing access to me as a trainer on the estimation side as well, because low slope roof assemblies are just, it's pretty hard to estimate for. So it's a lot of information in that 3-day period, but really it's just to get familiar with destructive testing and what you're looking for by attribute and by component. So yeah, it should be a great class.
I can tell you guys this, there's very few people in this industry that I would feel comfortable sending you to learn from. And Andrew is one of those people I feel very, very comfortable sending people to learn from. Very knowledgeable, probably has an answer to every question you possibly could present to him. And if he doesn't know the answer, he's actually going to tell you he doesn't know. He's not one of those guys that's just going to bullshit his way through. So he's got this 3-day class. I'm gonna throw up a link to that class so you guys have access to it, and maybe I'll put a coupon code on there. L2TB, L the number 2 TB will be the coupon code, and I'll force Andrew to give you guys 10% discount or something. But I'll put that in the commentary of this video after the fact, so you guys have access to that link. So come back to it after the thing is over, and we will come back to this topic soon, so that we can get into repairability. And I'll have Chad Williams with Valor Engineering, who is amazing and has been dealing with repairability of other types of roof systems for a while. And he's actually putting together a paper right now on repairability of single ply membranes. And so I really can't wait to get him on here to talk about that. But I think that's a full hour discussion all by itself. Next week is Valentine's Day, and ooh, I have not been able to book anyone for next week for some reason. I feel like they don't want to spend Valentine's Day with me. I don't know what it is. It's like no one wants to be my date. So I think we're going to skip next week. So two Tuesdays from now, we'll be back in action, but I'll see you guys then. Thanks a lot for being on the show, Andrew.
Absolutely. Thank you, Matt.
You guys have a good one.
See you guys.